Good morning, and welcome to the second part of the track B. My name is Heiko, I'm with Pebble, and first and foremost, I would like to ask who of you does not know what Pebble is? Or let me rephrase that, who knows what Pebble is? Wow, that's almost everybody. That's amazing. Okay, cool. So I don't need to introduce what Pebble does, but let me start with what I'm doing. So I have two roles right now at Pebble. One of them is actually UX, UI, and firmware related. So I'm with a team that enables all the developers to do all the graphics. The fact that we have colorful pixels in the first place is a result from our team's work. And then I do have a second role. We have a group of 3 WTF engineers at Pebble. And basically every single API that goes out into the world needs to be reviewed and signed off by these people. So we make sure that everything is consistent. And it doesn't mean that we are somehow superior to others or know better. It only makes sure that we make the same mistakes throughout the whole set of APIs. So with these APIs and all that, you can create amazing stuff. Who of you has anybody of you developed something for Pebble already? Like a watch face maybe? That's only a few. Cool. Maybe I know the reason. So we have a very vivid developer community, and they build all kinds of crazy hacks. So on the top left, for example, you see a nightstand that combines a supersonic sensor and a speaker on a 3D printed case to basically act as an alarm clock. You can wave at it and it talks to you. On the top right, you see a remote-controlled dog because Pebble has Bluetooth and you use the Android phone to remote control it. That's all nice, but I think the most crazy thing I saw was a laser powered and operated by Pebble. It's connected with what we call smart straps directly from the watch because you cannot have enough lasers with you. And then with plenty of sensors and you have access to all of that, you can build amazing things. So we have fitness apps, for example, that use our compass and accelerometer to count steps and give you insights to your fitness. But also, although it's a super limited embedded device, you can do fancy graphics such as those on the right-hand side. And full disclosure, I wrote that game on the right-hand side. It's a port of the popular Tiny Wings. And there's a reason why I bring it up here, because I will refer to that later. And then, because we are talking web here, there's a plethora of connected apps. So all these apps can basically connect to anything in the internet via our timeline thing, or because they can run JavaScript actually on the phone, and you can use that to remote control your thermostat at home or whatnot. But I think the main use case for us is really to ride watch faces. Watch faces where you have, as an end user, a customized experience, something that's unique to you when you look at your watch. And they can be informative, or they can give you insights to sports results or weather data. Others are just beautiful, and yet others are obfuscating the time, so you do not know what time it is at all. But in the end, it's all about customizability. There's one caveat, though, or maybe this is the reason why only one person here raised his hand. All the experiences I was presenting, they somewhat require you to program C. Now, my question is, who of you would consider themselves as being proficient with C, or does C programming on a daily basis? Exactly. That's not a single hand I see. And that's exactly the problem. When we have a very flourishing and vivid developer community, but we think that we can make it even better if it's not only accessible to those people who know and are familiar with C. And in fact, we run a weekly survey among our developers, and this is so there's lots and lots of positive feedback, such as, oh, it's so powerful or well documented. But a recurring issue is really, I don't know C. In fact, some people taught themselves C just to be able to program for the platform, which is amazing. But still, it could be so much more accessible at hackathons, for example, when we learn that people don't like writing C at all. And they are specifically asking for JavaScript to make it easier. And I can totally relate to that, although people say C is a rubbish language. Others say JavaScript is also not the best designed language. It's certainly more popular, and it's certainly more accessible. For me, it's not only about a programming language, though. When I'm doing software, it's all about exploration, speed, and playing with things until I finally figured it out and wrapped my head around it. And I can read books about programming languages, but what it really counts is that I have to create a mental model of what I think it works, how it works, try something, compile, and deploy it on the device again. And that cycle on Pebble, at best, is taking 10 seconds or something. So you are basically changing a number, let it compile, deploying to the watch, and then you see a result on that tiny screen without any inspector or debugger or breakpoints, nothing basically, to figure out what went wrong. Sometimes it crashes because it's C. Sometimes it doesn't show anything and you don't know what. And you're not C programmers, or maybe you cannot relate to that picture here, but it really feels like that. You do something, and then you have to wait for the machine for 10 seconds, maybe even more. So Pebble Wings, that game, requires me, I would say, 20 to 30 seconds to install on the watch. So if I want to make a little tweak, how does it look like if I move it up 1 pixel? Well, let's find out. And I forgot how it looked already after half a minute, and then I want to compare it to what exactly? So this is really not the workflow I wanted to have. So with Pebble Wings, I totally did it completely differently. So granted, in Pebble Wings, I didn't do it in JavaScript. Instead, and that was before I worked with Pebble anyway, I built a fake Pebble inside an iOS app. Because iOS was using Objective-C back then, and Objective-C is totally operational with C, so I could run that directly in my environment. And because that's super powerful, I had all the RAM at hand, all the development tools, quick turnaround times, and I could do things such as, oh, I just want to move forward 1 step. How does it look like if the sun goes down a bit further? Does that lighting actually work? How do these other level colors look like? Oh yeah, that looks better. And I can compile and reiterate in seconds. Now still, this isn't JavaScript, but you can do something very, very similar. So here, for example, I'm running a CrossCompile version of the very same thing. Because I had my virtual Pebble already, that was pretty easy. I used mscript in here to CrossCompile it and basically get the same result. So this is the full source code of of Pebble Wings. It has the mscript-based stuff, lots and lots of data, and then in the end, the actual compiled code. So I'm not saying that this is the most readable JavaScript, but it is running in the browser. And here you have the very same game running in the browser. And just to give you the idea, I implemented a few of these inspector toggles I used to work with while I was developing it. So I can basically stop it, run a single step here, and I also implemented this sun slider. And all that is running in the browser. I can set breakpoints here to look and inspect it, and I'm pretty sure you can imagine that I can put a lot of other little sliders and buttons on top of it to explore my game that would otherwise require me to recompile, install on the watch, where I have no way to introspect it at all except for log statements. So that's all great. And that was really a boost in the productivity. I would say that I wouldn't be able to write a game like that without better tooling. What if we applied these same ideas to Pebble development in general? Basically the same things. So Pebble has a very constrained platform, but if you want to explore some unoptimized algorithms or data structures, it would be very handy to have a few megs at hand to work with that. Otherwise, we're talking kilobytes here. I want to have fast turnaround times and also the familiar tooling, such as, I don't know, package managing or compiling or interactive debugging, actually. That sounds crazy, but I mean, the firmware is written in C, and script can cross-compile C. You can even cross-compile Quake. Why can't we cross-compile our firmware? And in fact, we did that to prove that. So when we recently introduced a few new APIs to our developers, some of them looked a bit more cumbersome and are harder to grasp. And I was presenting that in a slide like that, and they were blown away. Wow, how crazy is it that you can see a result next to the source code? That's amazing. It's so much easier to understand how this API is looking like. And here's the same thing. So here I'm changing a different variable. And they were just so amazed by that because they have no access to tooling like that. I mean, I don't need to tell you that tools such as JSBin or something allow you to do exactly like this for years. But in the C world, there's just there's no tooling like that around. So what I want to present you is how that would look like in the browser. So I'm copying that code, and I'm copying that into some JavaScript. And here I'm taking exactly the same code snippet. It's not valid JavaScript, though, because that's not, you don't declare types in JavaScript, and in ECMA 5 you do var here. So this is my code, and let me run this in the browser. And here's the result. So I have exactly this circle here, and it's a bit off-center. So let me change that to 10 and that to 10. And now this is pixel perfectly using our API rendering the actual result. And now I can play with it. I can see, okay, this inset, what does that mean? Oh, it's from the outside. So if I give it an arbitrary large value, it basically becomes a draw me a sector. This is what the example told me. Oh, this is 1, interesting. And 0, okay, so it's invisible with 0. I can quickly play with that. That's great. So how do the angles work? 300 is here. 0 is there. Okay, so it's starting. 0 is at the top, which makes sense because as a watch face developer, it's easy then to do minutes and hours and calculate angles from that. That means 90 should be at 3 o'clock. Awesome. Cool. So I can explore that just as if it was a web technology, and it's in fact here a web technology because we cross-compile the firmware drawing routines. And it also allows me to inspect that very carefully. So here I'm rendering to a canvas. I'm zooming that in a bit to show you some interesting effects. In fact, our drawing routines are not perfectly symmetric. If you look at here, I'm not sure that's really visible back then, but there's actually a gray pixel. Whereas at 90 degrees, there's not. And these are little implementation details that are really only accessible if you have the pixel perfect representation of what's going on the watch. Every implementation, I mean, you can build simulators over and over, but only if you have all the quirks and bugs and all that that also exist in the platform, you have the real true experience. And that's totally doable. And now, that might not be the most interesting case here, so let me go a bit further, actually. So it's a bit smaller again. And now I do have a set interval here. It's just JavaScript, right? And I have a value I change over time. Let's animate that. I say I start at 0, and I take value to go to use the end angle here. I see it's animating. Oh, that's a bit slow, actually. Let's make that a value here to have a nice animation. And then I learned in the other documentation that there are actually more routines, such as draw me a line. And I can say, go from one coordinate to, is that actually large enough to, can you read that in the back? I can probably make that a bit larger. So, so you have that now, and then I learn, oh, well, there's actually the ability to change the color. So you can say, set the stroke color of the context to be, I read there's a red. Okay, that's cool. It's a bit thin. So is there something about, yes, there's a stroke width. Yeah, cool. So I can explore that API very, very quickly. And I went down from compile and deployment cycles from 10 seconds down to really fractions of a second to play with these APIs and explore it. This is perfectly, except for this variable declaration here, the C code. So people can explore our today's C code. Well, I don't think it's the most convenient way to write this. Actually, I think I would rather write ctx dot and then stroke color equals property notation, like a color red, maybe even HTML or CSS color notation. Let's do something that's more realistic. So here, those of you who know Pebble might know the standard watch face the Pebble ships with. And I re-implemented what we internally call TikTok entirely in JavaScript, and I also build a few wrappers around it. And still, it's not pure JavaScript. It's actually taking the C code one-to-one, but making it a bit more, jazzing it up. So it looks like JavaScript. So instead of window create, you say new window, and then instead of window set handlers, you have a handler, and then you give it a dictionary or an object here, and then in the end you say window push, and you print something. And that's basically it. The core piece of a watch face is to have an update proc, which again uses our drawing routines. And here, not properties, still functions, but it is more looking like JavaScript when I say draw me a line, for example. And I'm changing this now. I'm changing it so that I'm scheduling another animation once the intro animation changed. So it now animates once and that's it, but it's showing the actual time. The interesting thing is that none of this animation system is actually something provided as a library, but it's entirely written in JavaScript with timeouts and intervals and whatnot. So you can build all that in JavaScript. Once you have access to the same drawing routines, you can build whatever you want because you have no constraints. You're running in the browser. Once we had that, it was super thrilling. What could we do from there? I mean, you have all the tooling. Everything is great. All we need now is a browser on the Pebble. Well, it's not that easy because of our constraints. So to give you an idea, today applications, their code plus their RAM must not exceed 64K. And I'm not sure you have an understanding what that actually means. And also I lied a bit because if we really want to do JavaScript, we could put some of that, for example, the whole JavaScript runtime into the firmware. And yes, we have a megabyte worth of firmware code, but it's already almost taken for the operating system. So we have roughly 200K available for code space, which gives you 200K for the JavaScript runtime, and then the application must fit into 64K. Does everybody know how much 64 kilobytes is? So I tried to find a good analogy. An iPad's app icon is 152 pixels, and if you only store 3 bytes per pixel, although they have alpha transparency technically, it's already exceeding these 64K. Or another perspective, if you just take Phantom.js, which is essentially a full-fledged browser with a JavaScript runtime, CSS, and HTML, and everything except for the browser Chrome, that on my hard drive was around 15 megs. We have 200K. Or I launched google.com this morning, and I looked at the Chrome developer tools to see how much JavaScript RAM impact it had. That was around 20 megabytes, and again, we have 64K. So a browser definitely is out of reach. What can you do with JavaScript then, today, even today? Well, there is this timeline API I was talking about. Yes, from the backend, you can push pins. We basically broke up this connotation of apps on the Pebble, and we ordered things chronologically instead, and you have access to that from anywhere through a REST API. So technically, yes, you can also push data or do post calls from JavaScript. Yes, well, yes, you can do that. Also, we enabled for more than a year now developers to run a JavaScript code on the phone, and then because the phone is connected via Bluetooth to the watch, you can use that JavaScript part to talk to some backend. And in fact, most of the applications I was presenting in the beginning were exactly following that route. They had some connected piece running on the phone, and then they were talking Bluetooth to the watch. That's all great, but you would still need some piece of C code running on the watch. And a coworker of mine presented that at last year's JSConf. That's called Pebble.js, building on top of that, actually. He said, well, the C part could be super dumb, and what if we totally remote control the whole UI from the phone side to make all that a truly JavaScript experience? While this is possible, it leads to a significant amount of lag. Because for every update, you would have a full round trip. And Bluetooth is really, because we are running so low power here, a few kilobytes per second, so you cannot transmit full-fledged images or anything. And then also you have some latency. Whenever you press a button, the watch needs to talk to the phone, and then the update needs to be communicated back to the watch. Does anybody here wear an Apple Watch? The original version, actually WatchOS 1, many people haven't upgraded yet, is exactly following that paradigm, and people are not too happy with it. And I wouldn't consider that to be the best experience. It's, for those of you who are not familiar with the setup, that's basically when you do, have you been to RobotsConf maybe? That's a very prominent way of doing it. You run in Johnny 5, for example, a node server, a pretty heavy instance, which is in our case our phone. You talk via either a USB cable or Bluetooth in that case with your board, and the board runs a very thin layer of Arduino code or native code and talks the same way. It's basically exactly that setup. And while it works okay with some setups for robots, if you want to do signal processing, it already has its limits. I will skip over the comparison with Apple Watch and Android Wear to go directly to our goals. So that whole setup is not exactly what we want. We want to have the true experience, all the sensor access directly, the ability to draw directly on the watch. And we don't want to have some crippled JavaScript-y lookalike thing. We want to have the ability to quickly go to Stack Overflow, Google something, how it's done in JavaScript, and paste it into our app. Basically the way we reprogram the web. So how can we do that? Well, others did it. Why can't we do it? There are actually embedded devices that run JavaScript. So some people consider the Raspberry Pi to be an embedded device, although you have megabytes, if not gigabytes, worth of data. And the Intel Edison is no difference here. But Tesla 2, for example, and Esperino, they run JavaScript directly on the board in a very limited fashion. And if you do some research, you actually come up with a couple of open source runtimes that implement a almost full 5.1, some aim for ECMA 6, JavaScript runtime to run on the embedded device. For this example here, I'm picking Esperino. The code size impact on the firmware side, so that's where we had 200K, is about 120, but it's not yet fully ECMA 5 compliant, and also there are a few other things that would need to add up to that. So, in order to do that, is that actually already the case? Is the demo part now? Yes. I'm basically taking exactly the watch face we had here before and copying that over to my Pebble project. And a Pebble project is technically a C application that there's nothing to, it's basically a C application, and I'm still compiling the C application, but the C part of that app I'm looking at is really just a one-liner. Eval me, please, that JavaScript part, which is here sitting in this text file. And now, to show you that on the real watch, I have this camera set up here. And I put my watch here, switch on the lights. And the way Pebble deployment works is by talking to the watch, this 10 seconds plus deployment cycle over the phone app. So what I'm doing from my computer now is I'm looking at my IP address, and I'm building and installing to the phone I'm connected with, which happens now. Here I'm installing. Then taking the logs requires me to have another communication, and here we are. So this is JavaScript running directly on the Pebble, but it also shows you how large the latency is. So it's not really JavaScript, it's connecting this whole setup. So if what did I do? Well, this looks really slow. Let me kill the Bluetooth connection here. So I'm going to that app again. Okay, so you see that animation can you see that actually? Let me go back to that. Is that loud? Can somebody confirm that you can see that? Is that bright enough? Okay, cool. Okay, cool. So this is really the very same, so this works better. This is really the very same JavaScript thing we saw before, the intro animation, and then the slightly scheduled thing after. And now I want to be able to use truly something with JavaScript. And I was looking for an example. So let's say we want to do Roman numbers JavaScript. I want to convert the current time into Roman numbers. I find some snippet. Oh, this is how it's going to work. And again, my development cycle is now to do that in my browser version because that's way faster. I paste it here, and let's say I'm just logging that. So I say Romanize, and then apparently I have a tick time here, and that has seconds. Okay, so let's do that, and I'm rerunning that. And now in the logs, I should see, oh, here we are. So that's 14, 15, 16, and so forth. But I really want to do the full time, so I want to have hours, minutes, and seconds. So I take this Romanize, which is basically the secs. I put that here, and then I'm copying that, and I say I want to have that as well for, I don't know, was that hour or minutes? Let's do that, and now I want to convert that to a string delimited by the colons. So I don't know, I will look that up. So that's JavaScript array join. Apparently it's just .join. So I say values join, and then that, rerun that, and oh yeah, cool. So that's super easy to see now that we have the short turnarounds. Here I have the full application. I paste it here. I recompile and install it. And I will already switch over. Actually, no, it should be pretty fast now. But I will switch over to the slides, and we see the logs piling in later. So that's all working. Why don't we ship it yet? We have JavaScript, we have the turnaround cycles, everything is achieved, but we have a couple of challenges. And basically, the main three challenges we identified is we have a lack of RAM, which basically means you cannot simply download the internet. Even going to Facebook to get your latest posts, I measure that is around 12K worth of JSON alone. So it will be very tricky to do that. Or memory ownership, and I don't want to go too much into that, but it's basically C doesn't have a knowledge of any garbage collector, so it's very hard to bring JavaScript and C together if you have a rich object-oriented API. And then last but not least, so JavaScript is often understood as I have the APIs that are available on the browser. But of course, if you don't have XHRs here, how do we actually accomplish that? How do we fit the JavaScript mindset if we cannot approach that? The good news is all the problems I was sketching here are basically API related. And you can explore all these API stuff, all these questions already with the mscript and cross-compiling approach I was presenting earlier. So we can use and iterate quickly in the browser and talk about how would it look like if we, for example, still would talk to the phone to talk to the internet. We could leverage the WebWorker API and offload work, which is memory intensive, to the phone. How would such an API feel and behave like? And we can totally build that in the browser without doing anything on the watch, so we can quickly explore that. Or memory ownership. What if we didn't do a full object-oriented API where it's unclear where exactly the data lives and who owns the data, but came up with something where you are declaratively describe, say, in a virtual DOM, how your UI would look like? That way, the manager in between has the responsibility, and you don't run into that issue in the first place. And then similarities, well, what is really best? Should we have the API that is tailored towards the need of a watch face developer, or should we go with the Canvas API, where most JavaScript developers know what they're doing, but some things today are not possible, others are a bit cumbersome to use? What's the best trade-off here? Should we actually go for the most concise API or the best known one? But again, we can build any kind of wrappers on top of what we have already to explore that. And that's exactly our goal for the next weeks and months. We really take that serious and investigate that. There's a part of the team that currently ports runtimes to the Pebble to see what the memory impact is, performance issues are. But there's also this question, how should we design the APIs to address these three problems we identified? And that's exactly where we would like to see your help and your engagement. So over the next weeks, we will actually publish these demos. So you can play with Pebble in the browser directly to see how it would look like and feel like. And we will explore different alternatives here. If you're interested in that, please go to that website. We set up a very simplistic website to subscribe to a newsletter. Before Christmas, we will actually make that public so we can explore that and collect feedback. There's one more thing. Aaron Hackman wrote that this morning to me. Pebble is awesome. We are hiring. That's it.